Hello, good day everyone. This is the extension of the enhancement program for the licensure examination for teachers of the BSMSCAT. This is exclusive for mathematics majors, and we are focusing here on problem solving. How to solve word problems in mathematics by using the concepts that we learned through the 4 years of stay in the school learning mathematics. Today we're going to solve a particularly common problem in licensure examination for teachers because it looks easy and some students fall for the trick, but there is actually a hidden mechanism for this that will allow you to solve this in a simpler way and arrive at a correct answer. If you're going to open your reviewer, this is actually number 10 in the reviewer. I'm sorry for the mistake. I've corrected the order of the choices because in Facebook, if you notice, it is posted in the Facebook group. The choices are randomized. Sometimes a value is in letter A, sometimes it's in letter B, to confuse the respondent so as to give an answer-centered response. The question goes like this: the sum of two numbers is 2, and the product of these same numbers is 3. Find the sum of the reciprocals. Often in the licensure examination, you'll see very similar problem. And before you can continue, the first step that you should do is to identify the given, because that's the first step in problem solving. Understand the problem, and that is to identify the given. Now we have the sum of two numbers, which is 2, and the product of two numbers is 3. And then we have what's required, and that's the sum of the reciprocals. Now for this type of problem, the initial strategy is to create an equation out of what's given. Often, if there are two numbers that are unknown, we're only required 2 sets of equations in order for us to identify the values for each variable, for each unknown. In this instance, let's try to create an equation. First, for the sum of two numbers. And that can be done by the expression x plus y equals 2, taking arbitrarily the value of x as one of the numbers and y as the other number. The second is to create an equation out of its product. We're going to write that in a mathematical sentence. You'll arrive at something like that looks like this. For this type of problem, often the way to get the value of each variable is to use one of the two equations, get the value for one variable, and plug it in onto the other variable on the other equation. For this instance, let's try to select a variable that we like to use, say y. So if we're going to get the value of y in, say, the second equation, all you have to do is to divide both sides by x, leaving you with a new expression, y equals 3x. And all you have to do is to replace y in the first equation with 3x, something that looks like this. Now you can solve this, but it seems like it's difficult because a variable is underneath a number. It's a denominator of a fraction. To deal with that, simply multiply the equation with x, all of the terms in the equation with x, leaving you with x squared plus 3 equals 2x. Rearranging this gives us x squared minus 2x plus 3 equals 0. If you want to verify that, get a piece of paper, write down the equations, and see for yourself. Now, you know that it's difficult to solve this problem with conventional method. As you can see, there is no pair of numbers that you can place with x that will give you a product of positive 3 and a sum of negative 2. That's just downright impossible. Again, if you want to verify that, get a piece of paper and try to get the factor of the quadratic equation through trial and error. Now another, and I guess this is the easiest method, is to use the quadratic formula. That looks like that. Value of x equals negative b plus minus square root of b squared minus 4ac all over 2a. All you need to do is to plug in the values for A, B, C. For this instance, A is 1 because it's the coefficient of x squared. B is -2 and C is 3. Now, if you're going to plug that into the quadratic formula, you'll get a solution set like this. First value is 1 minus square root of 2i, which means that 2 is imaginary. And the other value is 1 plus square root of 2i. The problem with this is it's difficult to get the inverse of each value and get its sum. Now, there is a simpler method for solving the problem, and that method doesn't require you to get the value of x and y. Let's go back to our previous equations, x plus y equals 2 and x plus y equals 3. Now, we have a third equation. If you're going to notice, we have the equation for the sum of the reciprocals. And if we're going to write that down, we don't need to complete the equation. Actually, it's not an equation, it's an expression. We don't need to complete it because it's what's required of you. Now, let's place it into consideration and probably look at it. We might see the solution from this. Okay, let's get the least common denominator of the two fractions because we're going to add them, and we can't add them if the denominators are different. Now, the LCD of the two fractions is obviously xy, and if we're going to convert each fraction into a form that has xy for denominator, we'll have an expression like this one. And now we can operate on the two fractions. Probably we can combine them, because since we have a similar denominator, we can write an expression with one denominator and combine the numerators now, giving us with this type of equation. If we're going to perform a sort of a rearrangement on the numerator, we'll get an expression that looks like this. And I think it looks familiar because the numerator looks like our first equation and the denominator looks like our second equation. And if we're going to replace the numerator with the value of the sum of x and y from our first equation, which is 2, we'll get an expression like this one. And if we're going to replace the denominator xy with the value for xy from our second equation, which is 3, we'll get an expression like this one. And I think we got the answer already. So if we're going to go back to the problem at hand, notice that, again, it's number 10, not number 8. Notice that on letter C, we have 2/3. Thus, our answer is 2/3. The question may not include 2 as the sum of the numbers and 3 as a product. It may be different. And you see, the trick here is to, if the question is like this, is to simply use 2 for the numerator and 3 for the denominator, giving 2/3. For instance, if you're given 5 as the sum and 7 as a product, then obviously the sum of their inverse is 5, 7, and so on and so forth. That's how easy it is. If you're going to try to solve this with the conventional method, you won't arrive at an answer. And all that you'll be doing is to guess the answer from the selection, which is not a good way. Now, I hope this explanation helps you, and I hope you encounter the same question on the licensure examination. This is the conclusion of our first tutorial on how to solve a mathematical problem like this. See you on the next video. Have a nice day.